Hello guys, welcome to the channel H2O, the A to Z of chemistry. Today we are going to begin with lecture 8 from the course S block elements, but make sure you watch the previous ones before doing this one. It's going to be very important today to have watched the previous lectures because what we are going to discuss today is going to be a compilation, going to be a revision of what you have already learned in the previous lectures. So we have been talking about the group 1 elements, that is the alkali metals, and today's topic of discussion is going to be the anomalous behavior of lithium. What does the word anomalous mean? Well, the literal meaning of the word is something which is different from the normal. So you all have been learning about the periodic classification of elements, and you know that in one group the elements, they have many properties which are similar to each other. But when we are going to talk about lithium, what we find is this is the first member of the group apart from hydrogen, which you know that is a unique element. So it has properties similar to group 1 as well as group 17, that is the halogens. If we start the group 1 elements, we have been always talking about from lithium to cesium. So we find that lithium, the first member of the alkali metals, this is different from the rest of the alkali metals in many of the properties. So we are going to discuss today about all those properties that lithium has different from the rest of the alkali metals. So essentially it is what we have already talked about when we were discussing the atomic properties, the physical properties, the chemical properties of the alkali metals. So today is going to be a compilation, a revision of all those things that you have learned previously but just put together so that it becomes very easy for you when it is asked in the examination to tabulate the various properties of lithium which are different from the alkali metals. When you are given various MCQs in your competitive examination and you have to tell in what respect lithium is different from the rest of the alkali metals. So that is what we will be doing today, a recap of the atomic, the physical, the chemical properties, understanding how lithium is different from the rest. So I am Dr. Ritu from the channel H2O, the A to Z of chemistry, and I hope you're going to enjoy your learning with me and you are going to have a wonderful time learning and revising what we have already learned before. So let us begin the learning. So first of all, as we begin the learning, we should be able to understand why does lithium show an anomalous behavior. And it is not only lithium that shows an anomalous behavior, all the second period elements, these are the first members of their respective groups. And all of these, they are different from the rest of the group members. Lithium is going to be different from the rest of the alkali metals. Beryllium is going to be different from the group 2 elements. Then we have boron to be different from the group 13 elements, carbon from the group 14. Similarly, nitrogen, oxygen, fluorine, all of these second period elements, they are different from their respective group members. Now, why do these show anomalous behavior? Some points are going to be similar to all of these and some will be specific for a particular group. But in essentially, you will find that all these second period elements to be different from the rest of the group members. So while is lithium having an anomalous behavior, the first point of difference between lithium and the rest of the alkali metals is that lithium, this has an extremely small size. It has the electronic configuration of 2s2, 1s2, 2s2. So it has a very small size. And if we go on to the lithium ion, it is going to be still further small in size because even the 2s shell is going to be lost after the loss of one electron from the valence shell. So both of these, the lithium atom and the lithium ion, they are very small in size. The next, again, because of the very small size, lithium, this has the highest ionization enthalpy. The electron is going to be lost very difficultly from the outermost shell. we have to supply a lot of energy to remove that electron from the valence shell in comparison to the rest of the alkali metals, which make it different from the rest. Then we have the highest electronegativity of lithium amongst the alkali metals. So down the group, as the ionization enthalpy that is going to decrease, the electropositive character increases, and therefore the electronegativity is going to decrease. So lithium, this has the highest electronegativity amongst the alkali metals. All right. So it can pull, or it has a tendency to pull the shared pair of electrons towards itself, which is going to be very, very important when we are going to see the covalent character in case of the lithium compounds. Then it has strong metallic bonding. Because of its small size, we see the strongest metallic bonds, they are present in case of lithium metal. The high polarizing power of the lithium ion amongst the alkali metals, again, this is going to make it very different. So just now we were talking about the high electronegativity of lithium also. So the high polarizing power of the lithium ion is what you have already studied in the previous lectures. While we were discussing various properties, we were talking about the Fajan's rule. So according to the Fajan's rule, smaller is going to be the size of the cation, more is it's going to be polarizing power. And this polarizing power and the rest of these all properties, well, this is going to lead to an increased tendency to form a covalent bond and also more solvation, more hydration. More is going to be the size of the hydrated lithium ion, and more is going to be the covalent bond formation in case of the lithium compound. So all of these, this is making lithium have some properties different from the rest of the alkali metals. Increased covalent character, this is also going to result in the increased solubility in the organic solvents, because like dissolve light, so covalent character increasing, the tendency to dissolve in the organic solvents is going to increase, and in the polar solvents is going to decrease. So now let us quickly see the different properties in which lithium is going to be different from the rest of the alkali metals. The first is going to be hardness. So lithium, this has the strong metallic bonds because of the small size. Therefore, it is going to be the hardest and it is going to be the lightest. As we go down the graph, the softness is going to increase, and because the atomic mass is going to increase, they are going to become heavier. The next we have is the melting points and the boiling points. So again, the strong metallic bonds going to be difficult to break in case of lithium. So lithium will be having the highest metallic melting points and boiling points. Around the group, the melting points and boiling points, they will be decreasing. Then we have is the reactivity. So lithium, this is least reactive, especially if we talk about the reaction with air and water. We find the lithium, this is the least reactive of all the alkali metals, but this is the strongest reducing agent. So if you remember the alkali metals, they can catch fire on exposure, be on exposed to air, and even the reaction with water is going to be a very violent reaction. All right, so we find that lithium, this is going to be very slow in its reaction with air and water. It does not catch fire on exposed to air, and it is slow to react with water in comparison to the rest of the alkali metals. But when we talk about the reducing properties, lithium, this is the strongest reducing agent. This is going to be important because lithium, this has high hydration energy. Therefore, this has the strongest reducing properties, right? The next we have is the action with oxygen. So we have discussed that in detail. So on reaction with oxygen, well, if it is going to be a controlled quantity of oxygen, all the alkali metals, including lithium, they're going to form the oxides. But when it is going to be excess of oxygen, lithium forms only lithium monoxide, whereas the rest of the alkali metals, they will be forming peroxides and superoxide. Sodium will be forming its peroxide, and the rest, potassium, rubidium and cesium, they will be forming the corresponding superoxides. The next we talk about the solubility of the various salts. So this is going to be first of all the oxides. So lithium oxide, this dissolves in water slowly due to its higher lattice energy, whereas the other oxides, they react vigorously. Then we have the hydroxide. So lithium hydroxide, this is a weak base and this is sparingly soluble in water, whereas the rest of the alkali metals, hydroxides, they are going to be strong alkalis and they are highly soluble in water. The fluorides, the carbonates and the phosphates. So these lithium fluoride, lithium carbonate, lithium phosphate, they are insoluble in water. And in case of the rest of the alkali metals, as we are going to go down the group, the solubility of the fluorides, the carbonates and the phosphates is going to increase. Next we have is the perchlorates. So perchlorate is going to be ClO4 negative ion. So due to the strong solvation of the small sized lithium ion, LiClO4 is soluble in ethyl acetate, alcohol and acetone. So this is because of its covalent character of the small sized lithium ion. We find that this is soluble in organic compounds. Alright, whereas the perchlorates of the other alkali metals, this is not going to be soluble in organic solvents like ethyl acetate, alcohol, acetone, because the cations, they are going to be larger in size, so the solvation is going to be less. So the next is the action with nitrogen. So again, lithium nitride is going to be formed when lithium is going to react with nitrogen, whereas the rest of the alkali metals, they do not react. In case of sodium, we do see a reaction with nitrogen, but it will be forming sodium azide, never sodium nitride. Alright, so lithium is going to be the only alkali metal which is going to be reacting with nitrogen to form a nitride. The next we have is the thermal stability of the alkali metal salts. So we see that the lithium salts, they are generally thermally unstable. For example, lithium hydrogen sulfide, this is thermally unstable, whereas the rest of the alkali metal hydrogen sulfides, they will be stable and fuse without decomposition. Next we have is nitrates. So this is what we have talked only in the last lecture. So we have lithium nitrate on thermal decomposition. This will be giving us lithium oxide, NO2, which is a reddish brown gas, and oxygen, whereas rest of the alkali metal nitrates, this will be forming the corresponding nitrite, and along with that oxygen is going to be evolved. So here it is oxide and NO2 and here it is only a nitrite. Okay, so this is an important difference that you have to remember, very frequently coming in the examination. The next we have is the carbonates. Again, this is what we have discussed in the last lecture in detail. So lithium carbonate is unstable to heat, whereas the rest of the carbonates, they are stable to heat. Lithium carbonate, this will be decomposing into lithium oxide and carbon dioxide. Why, how is what we have discussed in detail in the last lecture. The next we have is hydroxides. So again, similar trend we see for lithium hydroxide, unstable to heat, forming lithium oxide and water, whereas the rest of the hydroxides, they will be subliming unchanged. The next we have is the hydrolysis of the various salts. So we see lithium chloride hydrolyzing to a small extent in hot water, whereas sodium chloride, potassium chloride not hydrolyzing at all. Alum formation. So this is a property which is different from of the lithium sulfate from the rest of the alkali metal sulfates. All of the alkali metal sulfates, leaving apart lithium sulfate, they are going to form alums or double salts. So this is again what we discussed in the last lecture. So we talked about the nitrates, the carbonates, the sulfates last lecture only. So I hope you all remember. So the double salts or alums, they can be formed by all the alkali metal sulfates with the exception of lithium sulfate, which will not be forming alums. Now, one very important thing which you can remember over here, due to the covalent nature, lithium chloride, this is deliquescent. It can absorb moisture from the air till it's going to form a solution. And then it is also going to be soluble in organic solvents because of its covalent nature like pyridine and alcohol. Again, this is what we have discussed while we were talking about the various halides of the alkali metals in the chemical properties. So that would be all for this lecture. I hope you've enjoyed your learning with me, and now you know all the differences that lithium is having from the rest of the alkali metals. Now, very interesting is that lithium, this is different from its own group members, but it is going to be having properties which are going to be similar to magnesium, which is going to be the group 2 element. So it has a diagonal relationship with magnesium, similarity in properties with magnesium, which is going to be what we will be discussing in the next lecture. So see you again. Have a nice day. God bless you.